So here's my explanation for the problems in quiz number 4 in case you need some extra help. So the first problem we have is trying to find the limit of the problem. Since its x approaches to a finite number, the most intuitive idea is to substitute a number into it directly and see what happens. So 3 minus 3 over 3 squared plus 9, and clearly it's not 0 over 0, so it's a nice number we can use. Then we can carry out the rest of the calculation directly. So end up with 0 over 18 plus 6 plus 1. So I end up with 7, which is my final answer. You notice that I didn't really use equality at the first place here because technically I don't know whether they are equal or not. Before I finish my substitution, it could have been 0 over 0 type, so they don't really equal to each other. So I'm using this just make sure my notation is logically making sense. And if I look at the second problem, so I try to do similar discussion, I try substitution, it's root of 4 minus 2. Sorry, my iPad is not working very well. Root 4 minus 2, and then root 1 plus 1, and then 1 minus 1. So it's 0 times 2 over 0, which is a 0 over 0 type. Therefore, I know my problem, I need to do something extra. I can't really do direct cancellation, and factoring it is not intuitive. So what we are going to do is we are going to try to rationalize this expression by multiply the so-called conjugated structure, even though it's not technically the accurate term of it. So when I try to multiply the conjugate term, I do notice the second term here is actually giving me a 2. So there's no problem with it. All I need to do is to fix the first term, which provides me with 2 minus 2, which is 0. So when you try to multiply a term, you are supposed to multiply the expression, the conjugate of expression. That's causing issue for you in this particular case. It is only the root x plus 3 minus 2. So I'm multiplying the conjugate of that term. Make sure you do it to the numerator and denominator simultaneously, and then I'm filling in the rest part. And since I use equality, I want to make sure it's identical terms, so I'm carrying my limit. So you can use arrow if you don't use limit, but if you were to use equality, you have to write it as limit, so they are perfectly identical to each other. So the next thing we got is I'm trying to combine those two terms together. So what I end up with is the first term squared, which is x plus 3, and the second term squared, so 2 squared, which gives me 4. So the term that on left is root x plus 1. And then I have x minus 1. I have root of x plus 2 plus 3 plus 2 left. I'm sorry about that. So once we got here, this is x minus 1, this is x minus 1, they cancel out. So I have this expression with x approaches to 1, so I end up with limit x approaches 1, root x plus 1 over root x plus 3 plus 2, which is 1 plus 1 over 2 plus 2, which end up with 2 over 4, or 1/2, which is my final answer here for this problem. So if I look at the last problem in this part 1, I'm going to do substitution. It's 2 times 1 squared minus 1 minus 3. I'm sorry, it's negative 1. So minus negative 1 squared is still 1 minus negative 1 minus 3 over negative 1 plus 1, which is 2 plus 1 minus 3, 0. So it's a 0 over 0 type of problem. So I know I need to do factoring. And remember we said if x approaches negative 1 makes the polynomial to be 0, then x minus negative 1 must be a factor. Whatever makes your expression to be 0 when you do the replacing, then x minus that number must be a factor of the expression. Therefore, my problem can be phrased as limit x approaches negative 1. Nothing can be done on the denominator. The numerator must have x minus negative 1, hence x plus 1 as a factor. Then the only thing left for you to find is what's the other term after factoring. Since I need to produce 2x squared, it must be 2x times x. Since I need to produce negative 3 with something times 1, so it must be negative 3. So you can do a quick check on the side. It's going to be 2x squared plus 2x minus 3x minus 3, which is 2x squared minus x minus 3. So yes, they do multiply back to the original expression. So my calculation was right. Therefore, after the cancellation, my problem only have one term left in the numerator, which is going to be my 2x minus 3. So 2 negative 1 minus 3. I have negative 2 minus 3, which is negative 5 as my final answer. Okay, so let's move on to the next limit question. Well, its limit x approaches infinity, so if I were to imagine this as 1 million, and just to conceptually think about what's in the numerator and denominator, clearly both the square term would be dominating the behavior on the top and bottom. Therefore, what we are going to do, we are going to factor out the dominating term on the numerator and denominator. In this particular case, it's x squared. So what we end up with is 2 minus x over x squared minus 3 over x squared, and then you have 1 over x squared, and then you have 1 left. Some of the textbook explain it as divided by the dominating term, so they multiply 1 over x squared on the top and bottom. Mathematically, after you did that, you get the exact same expression. So I can have the cancellation. So what you end up with is going to be the limit x approaches infinity of 2 minus 1 over x minus 3 over x squared over 1x squared minus 1. So if I have x goes to infinity, keep in mind that a finite number 103 divided by something that goes to infinity, its finite number infinity is 0. So what you end up with is 2 minus 0 over 0 minus 1, which is negative 2, which is your final answer. So for the following problem you have here, it's conceptually the same idea. If you think about it, by the way, keep in mind e to the negative infinity is like 0, and e to the infinity, e to the infinity is like infinity. Therefore, if I look at my problem here, I end up with 2 times infinity, and then it's minus... I'm so sorry, something's wrong with my Apple Pencil. So if you conceptually think about the number to be, let's say, negative 1 million and see how things work, then you have negative 3 times negative 1 million, so positive 3 million. So it's e to the positive 3 million, e to the negative 1 million, which is roughly 0, e to the negative 5 million, which is roughly 0. So it's dominating up here. You can hold the same discussion. You realize this is roughly 0, roughly 0. It's again e to the 3 million. So those two are the dominating term. So what we are going to do is we are going to factor out the dominating term. See, I use arrow here because I didn't want to write the equals limit expression. So just make sure you write out your expression correctly. So I need to figure out what is going to be my exponent. So whatever was here, whatever is here, multiply that, gives me e to the x. So e to the x divided by e to the negative 3x gives me e to the positive 4x. So those two terms multiplied together gives me that, and keep going. So I would have 8x here. I would have negative e to the 8x plus 1 plus e to the 5x. So this multiply that gives me this term. This multiply 1 gives me that. And those two terms multiplied together gives me that. So my calculation makes sense. After I canceling the dominating behavior term, which would be those two, I end up with 2 minus e to the 4x minus 3e to the 8x over e to the negative, sorry, my bad, negative e to the 8x plus 1 plus e to the 5x. Don't forget you are sending your x goes to negative infinity. Therefore, every single term become e to the negative infinity. So what you end up with will be 0. So my expression is 2 minus 0 minus 0, negative 0 plus 1 plus 0. So you end up with 2 to be your final answer. So the problem gives you an answer of 2. The last question here, it asks for all the discontinuous points here. I don't need you to provide the justification. So just by glancing through all the functions, they behave nicely except this one. This one, we look at it, you should have x being 0, x being 5, and x being negative 2 be the three terms that makes your function to have a 0 denominator, so they are going to have the function value to be non-defined, namely problematic. However, if you take a closer look, it only works when x is greater than or equal to 1. For smaller than 1 cases, you're going to choose other rows, so you are going to have x being 5 to be only problematic, which makes your denominator to be 0, so you don't really have a function value. And it's going to be a finite number over 0 structure if you were plug 5 into it. So it is an infinite discontinuity because your function is going to be approaching infinity from the left or from the right side when your move approaches to 1. Then the next thing is I have 2 points where my function will cut at -1 at the point of 1. So technically, I don't really know whether they are discontinuous or not. So I'm going to just put it on the side and I'm going to check one of them at a time. So at the point of x approaches 1, so I'm going to say if I'm approaching to it from the right side, I'm going to have 1 plus 1 over 1 times 1 minus 5 times 1 plus 2. So it's 2 over negative 4 times 3. So it's 2 over negative 12. So when I'm approaching to 1 from the right side, I have negative 1 over 6. But if I'm approaching to 1 from the left, I'm going to plug in this number. So I'm having negative 1 plus 1, which is 0. So when I'm approaching to it from left and from right, I'm going to approach to 2 different heights. So I don't have a limit at the point of 1. So x equals 1 is a discontinuous point. The left and right limit are different, so it's a jump. Well, let's look at the last piece, x being -1. Well, if I'm approaching to -1 from the left, I read here, when I'm less than -1, my function value is 2, so I'm approaching to 2. When I'm at 1, my function value is 10, so I'm up here. And then when I'm on the right side of -1, I'm going to plug in here to find the limit because that's what's going on when x is greater than -1. So I have negative and -1 plus 1, which is 2. So it's height here again. So left and right, they're actually approaching the same height too, but the function is at a higher point at that particular piece, which is 10. So it's like continuous, but it has a circle in the middle. So I do have the third one as a discontinuity, but it's removable discontinuity. You don't have to find all of them. All you need to do is just find one of them when you try to classify it, but you need to list they are all discontinuous points. So that's all the explanation we have for quiz number 4.